Thank you very much to be able to give you some insight in what FAIR has meant for us in times of crisis. And the title is already indicating that we have, of course, started FAIR years ago. And under the pressure of the COVID-19 crisis that we are all facing at the moment, suddenly a lot of things around FAIR became fluid that were really stuck for a long time. Because FAIR is not only positive in the sense that it became a hype term, we have more than 3,000 citations on the paper. But when we published the original paper, I don't know whether the Mark you were mentioning was actually Mark Wilkinson or somebody else, but we have published the, uh, the FAIR principles, and many people have cited this paper and say they go FAIR in some way. But many of them have forgotten this sentence that is already there in the abstract, that we are really designing the FAIR principles because machines are now our major research assistants, and therefore we have to start publishing results, data for machines, so they can actually help us. So now I summarize in my lectures these principles that we are still pursuing very much in one sentence, and that is the machine knows what I mean. So the whole thrust of FAIR is that we publish our research outputs first and foremost for machines, and of course we still need narrative to communicate to people and to say what we did, why did we do the experiment, what is the reason that we drew these conclusions. And I call this a supplementary paper. So instead of publishing a paper with some supplementary data that are hidden behind narrative, which is a nightmare for machines. And if you're lucky, you can follow the link and find some understandable data for machines at least. We need to do this. So FAIR is all about the machine knows what I mean. And to achieve that, we have said we need to invest. And then people say, oh, you're stealing. And I just published, as you can see here, that we need to spend roughly 5% of the research budget of any research program on average on good data stewardship. And then people say, oh, but that is stealing 5% from the research budget. No, 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 no. Now we spend 80% of our time data munging before we can start our analytics. So if we all spend sufficient funding to make our data fair, and I'm just coming out of a workshop with the pharma where it saves them millions, and they confirmed that, then we will have more funding for research because we don't spend all this monk work on getting the data ready. They are fully AI, artificial intelligence, ready. FAIR is also fully AI ready. And when people now ask me, what will be my investment in FAIR? My standard answer is 10% of your savings. Okay? Now on to FAIR in times of crisis. So we started when the COVID epidemic broke out, we started the Vodon implementation network in CoFair, virus outbreak data network. You can read about it in this article. You will get the slides. It's recorded anyway. And the basic principle that we have applied there is that in COVID, the data that we need are, of course, the typical Elixir type data where we have the human protein atlas, UniProt, the literature. That is what we call established knowledge. It's open access where possible. Everybody can get it. And there is about 275 databases that we need to answer questions about COVID based on knowledge we have. If COVID induces a cytokine storm, which genes are involved in the cytokine storm? That is, of course, something we know in established knowledge. But what we are talking about in COVID here is what we call real world observations. Patient data, and they are under GDPR, they cannot be shared openly. So fair is not the same as open, okay? It is accessible under well-defined conditions. And the principle that we are now putting here is that of the personal health train, which means that the data are in a fair data station in the hospital or wherever they were collected, and the algorithms go to the data. So you send a virtual machine, an algorithm to the data, and it says, I'm from this university or whatever, or I'm even from a pharmaceutical company. Can I see your data? And can I ask certain questions to the data? Like, how many people did you give tocilizumab? We predicted that with Roche, and today it came out. It works against COVID in certain cases. Uh, how many people did you give tocilizumab or losartan or dexamethasone? How many did react? How many did get to the IC, to the intensive care? The answer will be given to the virtual machine, and it takes the answer with it, but it will never take the personal data with it. So the other thing I say is we start from a movement from data sharing. It's actually the end of data sharing. We go to data visiting. So the algorithm visits the data, not the other way around. And this is now working and implemented. That can only be done if we stick to very minimal principles, which we now call the fair digital object. And essentially, if we talk for non-techies, we say it means the machine knows what it means. And essentially, the machine has to be able to answer three questions. First of all, I encounter any digital record, any bit sequence in the web. First is, what is it? What's the type? Is it a single identifier? Even a single identifier for a disease or a gene needs metadata because we need to know from which thesaurus is this identifier. But then a triple, then a graph, then a database, ever larger containers of digital objects. So the machine has to be able, independently from humans, to say, what is it? A triple. Ah, then it knows from an ontology, what can I technically do with a triple? What kind of machine operations can I do on that? Or on a database, or on a graph, or on whatever. But a very important thing is, what am I allowed to do with this? That's metadata, informed consent in machine readable format to personal data, for example. And then the data can be anywhere in the world. The machine knows what it is allowed to do with them. Each digital object needs a globally unique, persistent, and resolvable identifier. We call this a GUPRI. So the machine gets a number, it knows, this is malaria, or this is COVID, or this is a gene. And don't use the term PSA, probably prostate specific antigen. It has 189 different meanings in Medline alone. However, this digital record could point to another digital record because metadata themselves are a fair digital object, and they point to this fair digital object. I'm the metadata of this thing. And why do we separate that? Assume this is a database of 5 petabytes of data. As a machine, I say, oh, there's interesting stuff here. Before I press the button virtually, download 5 petabytes, I better don't do that. So the metadata tell you things about the data, and themselves, they are also machine readable. And then this thing could point to another digital object, like a graph, a noded, a nanopublication, but also a physical object, like a sample in a biobank, or a butterfly sample in Naturalis, or natural history in GBIF. So the Internet of Fair Data and Services that we are aiming for, we need to communicate between humans and machines, but specifically now also machine to machine. So everything should be based on the FAIR guiding principles. The architecture should follow the FAIR implementation framework that I will say a little bit about. All elements should be machine actionable wherever possible. We make things obviously as open as possible. but of course as closed as necessary. Like I said, patient data cannot be made open, it's illegal. And we work as distributed as possible, as centralized as necessary. So the ideal situation is you have an application somewhere, could be a virtual machine, a little algorithm that travels the web by 5G or 4G. You don't need big cables. It finds data sources. It goes to the data source, does its thing, but it needs to know whether there is enough e-infrastructure, compute cores, at that particular location to do this. So this whole thing could be a smartphone. And the biggest supercomputer we have today is 8 billion smartphones connected by 5G. So essentially, everyone could have their own genome on their own smartphone. Technically, I don't say we should do that. And we could do a mutation analysis over 8 billion smartphones by 5G, not with light speed cables, because the data stay where they are. To make that happen, of course, the applications, the data sources, the infrastructure all need fair machine readable metadata so the machine is able to make the decisions by itself. The algorithm knows there is enough compute here to run this algorithm on this data set and take the answers home. This is what we applied in Vodon, and you can see here when you go to the website that this is supported by CODATA, COFAIR, RDA, the World Data System, and we have statements here that this needs to be distributed. It was funded by the Dutch funders and Philips, and this is what we did as an impression. This movie you can follow. You will see a movie on the personal health train. The trains are the algorithms. And here you see the Human Protein Atlas in Sweden, a company Euritos in the Netherlands, EBI, NCBI in the US. That's what we call the established knowledge stations. There you have the UniProts, the Human Protein Atlas, etc. That's what we call established knowledge. That's not the problem. We can visit them. The green dots, here is a big fair data point in China. Think about the idea that China would physically share data with the United States. Maybe after 20th of January, but as long as this orange idiot is there, there's no way there will be exchange between the two countries physically. So data sharing is not an option. But we can send algorithms to China, politely ask what can be done. If we could have done this in January this year, we would have known how to treat COVID patients much better in March, and we could have saved hundreds of thousands of lives. So, I'm coming to the last part already. What we did, we took all kinds of papers that are published about COVID, but mind you, on average, every day, 450 articles are published about COVID. It's a totally crazy circus, and many of them are crap anyway. Then you have the WHO case report form. Every patient that comes into our hospital, we measure 69 cytokines, 96 cytokines, 3 times. Imagine the number of data points. Then we have all the self-reporting apps. We make everything fair. Today, that's a painstaking thing, but in the future, this should be automatic. We have a WHO CRF form from 3 vendors, CEDAR, Castor, and our own one, that if you press save as a doctor, it creates RDF, which is fair data. We can take all the triples that come out of there, and then we have a hypothesis like ACE, ACE2. Everybody has heard about that maybe now. The virus binds to ACE2, but also we know 323 proteins that interact with the virus in the human proteome. Are you going to read all the literature about those 300 proteins? I don't think so. You talk 10,000 articles sometimes per protein. But we put this all together in the computer because now it is machine readable and it's done with Eurytos. Then we have a disease model, and I deliberately put this in a sort of petri dish. And this is what I do on a daily basis now. It's 46 genes that are involved in a particular model for disease progression to thrombosis and vascular leakage. And now people can test their drugs. And it's not a proof, but it is a rationalization. So we tested hydroxychloroquine, tocilizumab that came out today, uh, BCG vaccine, dexamethasone, aspirin, lidocaine, and so on. You can put them in this virtual petri dish and see whether it makes sense to the computer that the drug may work for COVID. And when we found out that prostaglandin E2 was up in all these patients that get their vascular leakage, so their capillary starts to leak in the lungs, so your lymph goes out of your blood vessels, and at the same time you get blood clots. Well, every layperson can understand that if that happens in your lungs, you're dead. So we can bring in experts, they look at this model, but this influx from the left-hand side has to be fair, otherwise it takes you months to get to the data. It took us months to get to the data for the model that I will show you in the last few slides. Just to say one more thing, in Leiden, but it could be anywhere, we have organ on a chip, real lung tissue, and we put the plasma of people with severe COVID through actual lung vessels in lung tissue. And we found out that if you do that from very sick patients with a very high level of prostaglandin E, first of all, the vessel starts to leak. Secondly, the endothelial cells in the vessel produce a lot of prostaglandin. And when the plasma comes out, the prostaglandin level is even higher than when we started. So there are precursors of prostaglandin in the plasma of the patients, and even the tissue gets sick because of that plasma. So now we have proof that an increased prostaglandin is a big problem. Then we have this disease model. Here you see the disease progression in the lungs. You can imagine this person is dead. You can put him on a ventilator, doesn't really matter. And we see that we start with the cytokine release syndrome, the cytokine storm, vasculitis, hyperemia, extravasation, and finally you die because either your lungs or your heart or your brain or everything starts to break down because you have vascular leakage and thrombosis at the same time. Here are all the genes involved in the model. And now I'm almost done, but this is what we now have. We took all the drugs that are now currently tested for COVID, and this is an artist impression, of course, from the real thing, and we threw them all together in the petri dish. So here you see, for example, hydroxychloroquine, which Trump is still saying should work, and only one link to the entire model, and that's a gene involved in arrhythmia. So it's dangerous for people with heart attack. Here you see BCG. It stimulates IL-6 like crazy, so it will cause a cytokine storm. So don't give it to people that get a cytokine storm. You see tocilizumab here, which gave a very good prediction, and it came out today. It works. You see dexamethasone. It's all here, and we can predict that it treats COVID. Finally, you see all the VIRs here that are antiviral drugs. They score very low in the model, very little, few lines, which is logical, but because this model is based on the hypothesis of disease progression and not on viral replication. And these drugs inhibit the viral replication, which is a completely different model. So we can have 4 different models on COVID and so on. So this is what you can do. But finally, this took us months to get to the data. If data would have been fair and visitable from January this year, we would have had this picture in March rather than October. Imagine. And now what we can do today, you see dexamethasone, you see prostaglandin E. Dexamethasone inhibits the production of prostaglandin E, and these genes they have in common. And this is a picture I can make in 5 minutes. So, to end with, we are setting this up now in the trusted world of Corona, where all the data that come in are made fair. They go to a personal locker, and the citizen can give machine readable. This app is now also ready. It's called Consentry. Machine readable consent. You can direct your data to a fair data station. A fair data point could be in your hospital or anywhere, which is endorsed by the Health Right or Elixir NL and Go Fair. And now you can start doing analysis on fair data points, and the machines who do that know exactly what is allowed. And we offer that in hotels and in rooms like this, the whole disease model, and people will throw their drugs in and rationalize vaccines, and we do this with many partners. This is actually running, and it gave FAIR an enormous boost. Actually, someone said to me, this breakout is your breakthrough, because all the things that bureaucrats were holding against FAIR, and all the people that said, oh, I'm fair because I have a PDF and you can find it and it's open access, they had to shut up now, because this is what FAIR is all about. And now we can do it, and we can do it for any other disease as well. So this was my keynote. I'm a bit passionate about this, but this is, not having your data fair is not only costing us now millions of dollars and euros, but now not having your data fair and have them reuseless is costing lives. Thank you.